Binary search is a search technique searching for a particular element that works for sorted arrays, and because it is sorted array it leads to lot of less operations. So it will search for the sorted arrays and it will divide the search space recursively. So let's say if I have to search for the element 23, I calculate, this is a sorted array. So now because uh, I know the idea here is, because I know that the array is sorted, and let's say if I'm looking for an element which is more than the middle element, then in that case I will look onto the right half of the list, and if I'm looking for an element which is less than the middle element, then I'll look in the left half of the list. This idea gets continued recursively. First of all, I'll compare with the middle element, and then if it is not so, I will compare to the left half or the right half. So here, let's say I want to search for 23. I look for the middle element, m is equal to 4. My number lies on the right half of the list. So I changed the low pointer to point to this, because now this is my area of search. I check the middle element 56, not 23, and my element is going to lie on the left half of the list. So I change now the high pointer to this. If I want to change the right end of the list, I come to high. If I want to change the left half of the list, I come to low. And now the middle element will be 23. So it will give me this. Let's say if my element was 38, then again it would have taken me to the same process, and then in that case my low, middle, high all would have been this 38, and then it would have given me the answer. Let's say if I'm looking for something that's not there in the list, then in that case this low value will become more than the high value. That is, low and high will not be less than each other, and so that indicates that the operation has to be terminated. I mean, it's not found. Till you have low less than or equal to high, we continue. We calculate the middle element, check if the middle element is what we are looking for. Otherwise, I change the low and the high. If my middle element is less than the target, that is, let's say if my middle element is 16 and I'm looking for 23, I change the low value to mid plus 1. Otherwise, I change the high is equal to mid minus 1. That is, I check, should I change the left end of the list or should I modify the right end of the list. So as we do this recursively, it will return the middle element in case if it is found. In case if it is not found, where low will become more than high, it will come out of the loop and it will return minus 1. So whenever minus 1 is returned, it will indicate that it is not found. Considering an example here, so let's say if I'm looking for 38, 27 initially is the middle element. So it will not be found, so I'll change the low here. Low will then point to 38, 43 and 82. Now 43 will be the middle element, and then again it will change high to be this particular value. So low and high are same, middle will also be same, and then it will check for this and it will come out of the loop. Consider I'm looking for 39. Then in that case what will happen is 38 it will check for, but then it will not be found. So it will change the, because it is more, it will change the low to this particular element, and low will become more than high, and then when the two pointers cross each other, then in that case it will come out of the loop returning minus 1 if it is 39. The complexity of this particular algorithm is O of log n. The complexity of linear search, where I am checking for the element one by one, is O of n. So here the complexity is much better when compared to the linear search algorithm. I will show the low is equal to 0, high is equal to the end of the list, till low is less than equal to high. I check for the elements. If check for the middle element, the low equal to mid plus 1 means search in the right half, high equal to mid minus 1 means search in the left half. Here for our understanding I am also going to print low and high. Let's say if I am looking for 9, so this will be my portion of the list and it will be found at one instance itself. Let's say if I am looking for 2, so it will search here in this portion of the list. 9, no, it will look with this portion 0 0, and then 2 is lesser, so it will become minus 1. High will be changed to minus 1, and so because the 2 pointers crossed each other, it will show not found.